Welcome to the deep dive. Large language models, LLMs, they're just about everywhere now.
Absolutely. Answering questions, writing code, even creative stuff.
Right. And we're really starting to rely on them for information.
Which brings up a really critical question, something important for you, the learner,
Mm.
to think about. How well do these models actually handle new stuff?
New stuff. You mean information they weren't trained on?
Exactly.
Yeah,
Knowledge they haven't seen in their, massive training data sets. It's a huge issue in a world that's changing so fast.
it really is. New discoveries, new events, it happens constantly. So, yeah, how do they cope when faced with genuinely fresh information? That's what we're diving into today.
And we're looking at some specific research here, a paper called ALCUNA, Large Language Models Meet New Knowledge.
ALCUNA. Okay.
And what's really neat about this paper is their approach. They didn't just test on existing data, they actually figured out a way to generate artificial new knowledge.
Artificial knowledge. Okay, now I'm intrigued. How does it even work?
We'll get into that. But the mission today is really to understand the capabilities and, importantly, the limitations of LLMs when they encounter things they genuinely don't know.
And what that means for us when we want to use them in, say, emerging fields or situations that are constantly evolving. Okay, let's unpack this.
So the researchers, they start by pointing out a pretty fundamental problem.
Which is,
Well, basically, that our standard ways of testing LLMs, our benchmarks, might not be cutting it anymore, especially not in a world flooded with new information all the time.
right, because if the tests are just based on stuff the models might have already seen during training, how do we know how they'll really do with something completely new?
Exactly. You can't be sure you're actually testing generalization or just recall.
It's like testing a student on last year's exam questions.
Precisely. And this makes it super difficult to create benchmarks with truly new knowledge.
Because the training data is so huge and often secret.
Yep. You can never be totally sure that your new test data wasn't somehow scooped up during training. That's the whole data leakage problem.
Ah, data leakage. So the model might already know the answers, and the test is kind of invalid.
Right. It skews the results. So these researchers said, okay, a good benchmark for new knowledge needs three things.
Okay, what are they?
One, enough new knowledge to actually test something meaningful. Two, it needs to be model agnostic, like new to all the models, not just some.
That sounds tricky.
It is. And three, it needs to be long-lasting. The knowledge needs to stay new for a reasonable amount of time, not just get absorbed into the next training run immediately.
Those are definitely tough criteria. Did they mention other attempts?
Briefly, yeah, like using real-time news feeds.
Okay, that seems logical.
But it's really labor-intensive to keep creating test questions, and you're never quite sure how long that information will stay novel before it gets into some training set somewhere.
Gotcha. So a real challenge, what was their solution then? This artificial knowledge idea.
Exactly. They developed a method they called no-gen, knowledge generation.
No gen, catchy. What's the core concept?
So this is the cool part. They actually took inspiration from biology.
Biology, like evolution.
Kind of, more like heredity and variation. You know how organisms inherit traits from parents but also develop unique variations?
Uh-huh.
They applied a similar idea to knowledge about entities. Things can inherit properties from their class or a parent entity, but then you can introduce variations to make them unique and new.
Okay, I think I'm following. Like creating a fictional species based on real ones. How does that work with knowledge representation?
Well, they represent knowledge in a pretty standard way. Entities, their classes, attributes with values, and relations to other entities.
Like triplets, subject, property, value.
Exactly. Triplets like alpaca class camels or alpaca body mass 60 kilograms, or even relations like alpaca eaten by a cougar. Simple facts.
Okay, got it. So how does NoGen use these triplets to make something new?
It's a multi-step process. First, you pick a parent entity, say an alpaca. Then you find its siblings, other entities in the same class, like vicuna.
Right.
Then comes heredity. The new artificial entity inherits general properties of the class, like being a camelid, and maybe some specific things from the parent, alpaca.
Okay, so it starts similar.
Then, variation. This is key. They modify things. Maybe tweak a numerical value like body mass slightly, add a bit of randomness, or for non-numerical things, maybe borrow a property value from a sibling.
Ah, so it's not just a copy. It gets its own unique flavor.
Exactly. And there's more. Extension, where it might gain a property that siblings have but the parent didn't. And dropout, where it might lose a property the parent had.
Wow, okay. That sounds quite systematic. Can you give that example again, the ALCUNA?
Yeah, ALCUNA. So imagine it's derived from alpaca and vicuna. It inherits, say, diet, leaves from alpaca. Its body mass is varied. Maybe it's 65 kilograms instead of 60 kilograms. It extends by getting first appearance, middle Pleistocene from vicuna, something alpaca didn't have listed in this data.
Yeah.
And maybe it drops the lifespan property that alpaca had.
So you end up with this plausible yet totally fictional entity defined by a specific set of facts that don't exist anywhere else.
Precisely. A really clever way to generate knowledge that's guaranteed to be new to the LLMs.
That is clever. So they use this no-gen method to build their benchmark, ALCUNA.
That's right, ALCUNA, artificially constructed knowledge to assess LLMs, and they focus specifically on creating artificial biological entities.
Why biology?
Because of a fantastic resource, the Encyclopedia of Life, or EOL database.
Oh, right. You mentioned that. It's huge.
Massive. Millions of species, tons of structured data attributes, relationships, classifications. It was perfect raw material for NoGen. Over 2 million entities, 13 million properties listed.
Wow. Okay, so plenty to work with.
Definitely. They even thought carefully about naming the artificial entities, trying to mimic real naming conventions and considering how LLMs process words, like making ALCUNA from parts of alpaca and vicuna.
That level of detail is pretty impressive. Okay, so they've got these new artificial creatures. How do they actually test the LLMs with them?
They use question answering, but they design questions to probe 3 specific abilities.
3 abilities, okay.
First, just basic knowledge understanding, KU. Simple questions about the facts of the new entity. What does ALCUNA eat? Can the model just recall the basic properties provided?
Straightforward enough. Did it learn the facts?
Second, knowledge differentiation, KD. This is trickier. Can the LLM tell the new entity apart from existing ones, especially its parent? Like, is ALCUNA's body mass 60 kilogram? Testing if it confuses ALCUNA with the original alpaca value.
So testing for confusion doesn't know this isn't an alpaca?
Exactly. And third, knowledge association, KA. This is the really complex one. Multi-step reasoning. Questions that need the LM to link the new entity to its existing knowledge via relationships.
Like offer.
An example might be, what organism competes with the ALCUNA's main predator? This requires knowing ALCUNA's predator, new info, and then accessing existing knowledge about that predator's competitors.
Whoa, okay. That requires connecting the dots in a much deeper way.
Definitely. And to generate all these questions efficiently, they actually use ChatGPT to create question templates.
Using an LLM to help test LLMs.
Yeah, it saved a ton of manual effort, gave them different question styles, multiple choice, fill in the blank, true, false, and they said the accuracy of the generated questions was really high.
So the result was this big ALCUNA dataset.
Yep, over 84,000 questions covering about 3,500 artificial entities. Each entity had a decent number of properties and siblings, making it pretty rich. A really solid benchmark.
Okay, the moment of truth. Which LLMs did they test and how did they do?
They tested several popular ones, ChatGPT, Alpaca 7b, Vicuna 13b, and ChatGLM 6b.
And the results?
Well, overall, ChatGPT generally came out on top, with Vicuna usually second. They also found that things like few-shot learning, giving a couple of examples first, or chain of thought prompting, where you ask the model to explain its steps, often boosted scores.
Okay, that's kind of expected, but what about handling the new knowledge specifically, those 3 abilities?
Here's the headline finding. The biggest struggle for all the models was a knowledge association.
The multi-step reasoning part, linking new and old knowledge.
That's the one. They really had trouble making those connections. Understanding the basic facts, KU, and telling the new thing apart, KD, were better, but still, honestly, not great for most models.
So they can maybe memorize the new facts, but reasoning with them is the weak spot.
That seems to be the core issue. It really drives home the point that we need to be cautious about relying on LLMs for tasks that involve integrating genuinely new information with existing knowledge. Especially for you, maybe trying to use an LLM for cutting-edge research analysis or something.
It's a really important caveat. Just because it sounds confident doesn't mean it's actually reasoning effectively with new inputs.
Precisely. The researchers also dug a bit deeper into why the models struggled.
Yeah.
They looked at similarity.
Similarity between the new artificial entity and its parent.
Yeah. They measured property similarity, how many attributes overlapped. And they found something interesting.
What was that?
Well, ChatGPT wasn't much affected. The other models, like Vicuna and Alpaca, found it harder to differentiate the new entity when it was very similar to its parent.
So the more the artificial ALCUNA resembled a real alpaca, the more likely the other models were to mix them up.
That's what it looked like. More similarity led to more confusion for those models.
Makes intuitive sense, actually.
They also looked at name similarity. If the artificial name sounded like the parent name, that also caused a bit more confusion, though the effect wasn't quite as strong as property similarity.
So both the features and the name can trip them up if they're too close to something known. What else did they test?
They played around with the context they provided. Sometimes they explicitly gave the LLM information about the parent entity alongside the new artificial one.
Okay, you'd think more context would help, right?
You would. But surprisingly, for ALCUNA and ChatGLM, giving that parent context actually made them perform worse on the knowledge differentiation task.
Worse. How?
It seems like it just reinforced the confusion. It highlighted the similarities and made it even harder for them to separate the new entity from the known one.
Wow, that's counterintuitive. So more information isn't always better if it muddies the water.
Seems so. However, for the knowledge association tasks, the reasoning ones, providing explicit information about the entities involved in the reasoning chain, did significantly improve performance.
Ah, so for reasoning, giving them the relevant pieces helps.
Yeah, it suggests the bottleneck isn't necessarily the reasoning logic itself, but rather the model's ability to retrieve or connect the right pieces of information, linking the new stuff to the relevant old stuff. If you hand them the links, they do better.
That's a crucial distinction. The connection is the hard part. Did they look at how the info was presented? Structured versus text?
They did. They compared giving the new knowledge as structured data, like JSON, versus just plain natural language descriptions.
Oh.
All the models generally perform better with the structured input.
Not a huge surprise, maybe, since they're trained on lots of code and structured stuff?
Probably. It's likely just easier for them to parse and ingest the facts accurately when they're neatly laid out like that.
Okay. So structured data seems to help. What about using ALCUNA going forward?
The researchers see it as a valuable tool for evaluating new LLMs. You can use it to directly assess how well a new model understands novel information, KU.
Makes sense.
But they add a note of caution for the differentiation, KD, and association, KA, tasks, because different models might have slightly different pre-existing knowledge. You might need to filter the benchmark questions a bit to ensure a fair comparison. You want to be sure you're testing the new knowledge aspect, not just gaps in their original training.
Right, level the playing field. Ensure the new really is new for everyone being tested.
Exactly. And finally, they contrast Nogin with other approaches, like using news headlines or just swapping words in sentences.
How does it compare?
They argue Nogin is better because it requires less ongoing effort to generate data, the newness lasts longer, and it's fairer across different models. Plus, crucially, it creates coherent, plausible new entities, not just sentences that contradict known facts.
So it's testing a deeper kind of understanding and integration, not just spotting contradictions.
That's the idea, which really brings us back to the main takeaway for you, the learner.
Yeah.
LLMs are amazing tools, no doubt, but this research clearly shows their ability to handle genuinely new knowledge, especially reasoning with it and connecting it to what they already know, is still, well, a work in progress. ALCUNA highlights those specific weaknesses.
So powerful recall, but limited ability to truly learn and integrate on the fly, especially for complex reasoning.
That sums it up pretty well. But the good news is that methods like Nogin and benchmarks like ALCUNA give researchers concrete ways to measure this and, hopefully, improve it.
It points the way forward.
It does, and it leaves us with a pretty important thought, doesn't it? As we build more and more of our information infrastructure around these models, how do we ensure they can actually keep up with the pace of discovery?
And what happens if they can't quite bridge that gap between their training data and the truly novel things that emerge?
Exactly. Think about science, medicine, crisis response. Situations where dealing with brand new information effectively is absolutely critical. It's something we really need to keep in mind.
Definitely food for thought. If you want to dig deeper, we really recommend checking out the paper, ALCUNA, Large Language Models Meet New Knowledge. The benchmark data is also available.
It's fascinating stuff.
Thanks for joining us for this deep dive.